So thank you very much for being here today. I'm really excited to have an opportunity to talk to you. As you heard from Sunshine, my background does relate to adaptation, but it relates also to water. I was a water manager for the state of Arizona for 23 years and designed a lot of the adaptation and conservation management programs that they have in Arizona prior to becoming a professor, prior to working in the White House and running the U.S. National Climate Assessment, which was by far the biggest challenge I've ever had in my life, but also the most fulfilling. And so what I have been asked to do today, when we actually get to open the slides, is to share just a little bit about both the process and the outcomes of the National Climate Assessment, because it actually was conducted in a very different way from previous efforts of its kind. And so I'm going to just dive right into it and tell you a bit about what we were up to. So I wanted to just share briefly why it is that we do national climate assessments. The main reason is there's a law that requires it that was passed actually in 1990 prior to the fact, during the Bush administration, the first Bush, before the fact that climate change became a political football. But the law that requires it says that every 4 years there's supposed to be an evaluation of what it is that we know and how we know it and what we still don't know about climate change. And in fact, though the requirement was to do it every 4 years, in fact it's only been done twice before this last one. And there are many reasons why that's true. The main reason I think is that it's actually a very difficult thing to do, to try to synthesize all knowledge related to climate change across the entire United States, in every region, in every sector, and really identify what's still unknown. But when we started this last process, which was actually around 2010, the beginning of 2010, our assignment was actually to build a different kind of national climate assessment. This one is built to support decisions. So it's intended to help people anticipate what it is that's coming in the future, work on mitigation, which we refer to as managing emissions, and adaptation, which we also think of as managing risk. But in doing so, the idea is not to have this just be a federal government activity, but actually have this be focused on all the people who are on the ground, observing what's changing and making decisions. So a very inclusive process that's broad-based and sustained, as opposed to just writing a report every 4 years and going home. The idea is to build sustained capacity to do this kind of work over time. There are many things that are new about this assessment process as compared to the two previous ones. One of them is that there's a very broad engagement strategy. We had about 300 authors. We had an enormous Federal Advisory Committee, about 60 members. We actually made them tell us how they came to their decisions and write that down. It is in a risk-based context, which means it's about decisions and managing risk, not just about saying what we know. So it's really in that kind of decision framework. The idea also was to evaluate how well we're doing in adaptation and mitigation, not just talking about climate impacts, but talking about how well the country is doing in preparing for those impacts. And also trying to build a sustained scientific and rigorous process for continuing to do this kind of work over time. But possibly most important to all of you, it was delivered electronically, and we don't mean we sent in a PDF. This is actually an interactive website. It's completely groundbreaking from that perspective. The link, and I think maybe the contents, are in the little USB that they gave you. But we really recommend that you go to the website and check it out, because it is a new way for government reports to be delivered. The highest level messages, which are sort of the consensus findings from these 300 authors, was first of all that human-induced climate change is here and now. It's not something that we just need to think about for our grandchildren. We are now observing the impacts Americans are feeling the impacts in multiple different ways, including changes in the number and types of extreme events. The impacts are evident everywhere we looked, in every sector, in every region. But also, we didn't want people to feel hopeless about all this. There are, in fact, many things that can be done, both to limit the effects of climate change and to manage the risks. And so we wanted to emphasize those points as well. The website is listed at the top right of this slide. It's basically nca2014.globalchange.gov. There are many written products as well. We had a truly amazing rollout process. There have been 10,000 articles about the assessment in the last year. We had 1.5 million hits on the website within, I think it was 2 months. So from a communications perspective, it's been a huge success, at least from my perspective. I hope many of you are already using it as a resource. But we also have many written sort of handout type reports as well, a highlights document that's 140 pages. There's multiple 2 to 4 page handouts. Everything's free. There's Spanish language translation, which is actually on my own website at the University of Arizona for reasons that we don't need to go into. The website itself has really received a lot of attention. So as far as the findings are not dramatically different in terms of their fundamental physics from what we've understood for a couple of decades. Basically, you add more energy to the atmosphere and lots of things happen. First of all, you get more water vapor in the air, you get warming of the sea surface, warming of the land surface, melting of ice, etc. So these are all things that are currently being observed, and all of which are consistent with adding energy to the atmosphere. And lest anybody think that we made any of this up, unlike previous assessments, all of the data behind these conclusions are actually accessible. They're a click away. You just click on the graphic and it takes you behind the graphic to the sources, and behind the sources to the data. And here are the data for those arrows that I just showed you on the previous slide. So as you can see, you don't even need to know what the titles are at the top of each one of these graphs. There are very obvious trends in each one of these categories, and they're all consistent with what we understand about the physics of the universe, or at least the globe as we know it. So the other component of this, which is now truly unequivocal, is the human contribution to climate change. And we know this now multiple different ways. One of the ways that we know it is that I'm going to try to show this with yes, this works. So the observed trend is what's going on with this black line here. If we take into account only the natural factors that cause changes, such as previous ice ages and warming episodes, we would be along this line here, which, as you can see, is actually a slight downward trend. We would actually be in a cooling period right now if it were not for the contributions of human beings. But where we actually are is going up like this. So it's actually counteracted this historic cooling trend caused by the tilt of the Earth's axis and the distance from the sun and what happens with volcanoes and all those sort of natural variability causing events. And instead we're heading upwards in this trend that you see here. So the pink area is actually, when you model natural and human factors, we pretty much nail it in terms of what we're actually observing. But the other way, there are many other ways, but they include, for example, being able to trace individual molecules of carbon dioxide that are in the atmosphere to specific power plants and emissions sources. So we understand what's happening to the chemistry in the atmosphere, and we're able to model it pretty accurately. Another thing that is new from this National Climate Assessment is the connection of extreme events to climate change. Now, not all extreme events are connected to climate change, but it is true that all climate is now affected by what it is that we're doing. So in some level, the extra energy in the atmosphere is affecting all weather events. And one of the things that we're seeing is that the cycle, including the jet stream, is actually changing from the way it has behaved in the past because of what we are doing to the atmosphere and because of the changes in the poles and other various processes that are all connected to all of this. And by the way, all of the graphics for the National Climate Assessment are available online, and there are presentations for every chapter. And so if you need anything, it's all very readily available for your use. Yes?
Are you saying you've been able to link a specific event?
So what has been done is statistical analysis of the likelihood of individual events occurring in the absence of climate change, and they have been able to conclude that certain droughts and certain other events that have happened, heat waves, etc., are so unlikely in the absence of climate change that they're concluding that it's largely attributed to climate change. But no, it is not possible to say that any individual event is entirely because of climate change. We've had variability since the beginning of time, but climate change is significantly affecting the magnitude of many of these events. So in terms of the findings, and there were 12 high-level report findings, first of all, global climate is changing. It's apparent across the entire United States, but importantly, it's not felt exactly the same way everywhere. Looking across the last 30 years or so, there has been quite a bit of warming in the southeast, but over a longer period of time due to natural variability, actually the southeast has not felt as much warming as much of the rest of the United States. So people don't feel it all the same way, but we are seeing impacts everywhere in the United States. The global warming of the last 50 years is primarily due to human activities, as I just explained, predominantly the burning of fossil fuels. A lot of recent extreme weather events have increased. There's stronger evidence that confirms that those increases are related to human activities. So this one is a particularly important one. The intensity of precipitation, a 71% increase in the Northeast in the volume of water that is falling in heavy rainfall events. And in general, across the whole northern tier, there's a very significant increase in the intensity of precipitation. It's actually true across the whole country, but it's particularly significant across the northern tier of the U.S. The last, I think it is the 60 years, the last 60 years, but you can get the specifics from linking right on the assessment itself. So human-induced climate change is projected to continue, and it will accelerate significantly if we don't manage emissions. So what you see on the left-hand side here is essentially the amount of temperature change we expect to see by 2100 if we don't manage emissions more stringently than we do today. Essentially looking at a 3 to 4 degrees Fahrenheit increase over the next 85 years versus something like an 8 or 9, at least in Arizona where I'm from, degree Fahrenheit increase. This is incredibly significant. So think about how much impact there's already been from essentially 1.5 degrees Fahrenheit change. The idea that we could have 3 to 4 or maybe 7 to 8 degrees of additional increase over the next century or over this century is a little frightening to me, especially given that these are average temperature increases. This does not tell you anything about the extremes, but it does tell you that the future is very different if we manage emissions than if we don't. Other report findings, widespread impacts related to climate change are already evident in many places. There are larger and more intense wildfires, more flooding in certain parts of the country, more intense heat waves and droughts, and more intense hurricanes. So there's a lot of evidence that things are changing. Human health is one of the ways that many people are actually experiencing this, whether it's because of heat waves, changes in air quality, migration of disease vectors. There's a whole range of different things that are happening with human health that have been linked to climate change. We also did do an assessment, as I mentioned, of how well we're doing in adaptation and mitigation and decision support. And the conclusion is that we're not doing enough to manage emissions. In fact, we're actually headed towards that higher emissions trajectory, not the lower one, and that we're not doing enough to manage risk, though obviously many people who are at this event that we're attending this week are doing everything they can to manage risk, and that's very heartening. So there is a lot of progress, but probably not enough. And most of the impacts of climate change are felt in one way or another through the water cycle. So that's one reason why I feel very closely connected to this topic. Is I've been a water manager for almost a quarter of a century in the state of Arizona, and that has really opened my eyes to the changing implications of what's going on with the climate. Whether it's endangered species, it's flooding, it's drought, it's fire, water supply. There are many ways that the water cycle is affecting communities, sea level rise, glaciers melting, etc. And looking specifically at the impacts of change on the water cycle, first of all, big changes in snowpack, which is the source of water for many of Western communities and is a huge issue for the state of California right now. Changes in the timing and seasonality of runoff, which has big implications for ecosystems and species. Lots of implications for recharge of groundwater aquifers. The changes in surface water runoff affect the degree to which groundwater aquifers are being recharged. Water temperature and quality, huge impacts, because when you raise the temperature of water, the amount of oxygen that it can hold reduces, and that actually reduces how much biological diversity can be supported by the water. In addition, big storms cause a lot of sedimentation and also runoff of pesticides and so forth. So lots of impacts. And then, of course, the obvious ones, floods and droughts. Wrapping up here, I just wanted to mention one important opportunity that was created by the National Climate Assessment. We partnered with 150 different organizations, both to bring their data to the table and to share the outcomes of the National Assessment, which is one of the reasons why the communications effort was as strong as it was, is we have a communications affinity group in this team of people. They continue to meet monthly through a webinar, and you're all welcome to join. It's a completely open process. You can also look online at the ncanet.usgcrp.gov, and there are also resources at ncanet.gov, and that actually has links to a lot of the graphics and a ton of additional resources. There have been lots of responses to the National Climate Assessment, including state and local efforts, as I mentioned, with 10,000 different citations of the assessment. Obviously, people are paying attention to it. And here is my contact information. I'm more than happy to take questions, and in fact, I think we still have some time.